Data is all around us, and we used to store data on paper in big filing cabinets, but eventually, we store them online in what we call databases. But how do we easily pull the data that we want to look at? That's what SQL is for. It's a language that communicates with databases. And SQL stands for Structured Query Language that lets you access and manipulate databases.
What is SQL? SQL stands for Structured Query Language. SQL is used to communicate with a database. According to ANSI, or American National Standards Institute, it is the standard language for relational database management system. SQL statements are used to perform tasks such as update data on a database or retrieve data from a database.
These days, almost everyone has to work with data in some form or another. Usually, it's through spreadsheets or databases. But if you can learn a little SQL, you can become so much powerful in your job. Let me define a bit of what I know about SQL. So, SQL is a powerful and robust tool for extracting relevant and useful data from a large data set. It is important to learn SQL because learning SQL can not only enhance your skills, but it can also give you a better understanding of applications you work with on a daily basis. And also, learning SQL allows you to consolidate data from multiple data sources and convert complex datasets to actionable intelligence.
How did SQL change the world's view of database management system? With massive data currently available, businesses and industries are collecting and churning out billions of data every day. The big data phenomenon requires a proper skill set to be able to make meaning out of it, be it in the medical field, education, business, sports, and etc. These enterprises must be able not only collect and store data, but also analyze it to make strategic and informed decisions that can increase their profitability and solve real-life problems. Imagine being able to use big data to design a model that will ease traffic and make transport in major cities easy and convenient. These and many more can be done, and one of the skills needed by a data scientist is SQL. As a free open source programming language, SQL is at the very foundation of data science. Communication with relational databases will be easier when you learn SQL. I would recommend that any aspiring data scientist should learn SQL because it is easy to learn, helps in a deep understanding of datasets, integrates easily with scripting languages, manages huge datasets, and is indeed a gateway to lucrative data science jobs. So, before you begin learning other programming languages for data science, why don't you begin with SQL and have a cool entry into data science?
Hello, I am Showbee Lumanta, and we're having a walkthrough with database management system using SAMP. SAMP software package contains a patch distribution for Apache server, and it is basically a local host or local server. This local server works on your own desktop or laptop computer. The use of SAMP is to test the client on your website before uploading it to the remote web server. In order for us to use SAMP, we must download and install the software into your computer. It is completely free and available on their official website. After the installation, we need to enable some things in the SAMP control panel. So this is the SAMP control panel. SAMP control panel is the management tool that offers to supervise the actions of individual components of SAMP. We need to enable the Apache module and the MySQL, since since SQL is the language that we are going to use. After that, we need to click the admin for us to go to their local host, or you can just type it in your browser. Then click New to create a database name. Tutorial. Create. So, in our scenario, we already created a CSV file as a table for this website. Click Import, choose File, Employee, then Go. Click the employee, structure, check all for us to change the name of the columns. First, employee ID, first name, last name, email, address, and lastly the employee number ID. In data type, for first name is varchar and an employee ID is integers, so as the last name, email address. And for employee ID, and the department ID is int. The length is, and for the length you can set the maximum number of characters that you can store in an attribute. Let's give 11, and in the first name is 255. And the department ID is same with the employee ID. Then save. As you can see, we've changed the columns. Then let's try. Now we can try to select and show columns for the table. To select column and its value, we must use the keyword select. Remember that SQL is not a case-sensitive language, therefore you can type the words in lowercase, but by convention, using capital letters for keywords is used in order to identify keywords from not keywords. Say for example that you wanted to extract all the names of the student, so we just type the edit inline field in syntax. For example, select name from employee. First name, sorry. So, this is the result. In order to select the distinct values in an attribute, we use the distinct keyword. For example, we wanted to know only the locations of the employees. So select distinct address from employee. So it shows the address and the output would be the address of the employee but without a repetition. Let's try the count. Select count first name from employee. The count function returns the number of rows that matches as specified. And that is the basic of selecting values in database. On the next lesson, you are going to learn how to filter results in order to obtain result based on the conditions.
Filtering data in a table. We will learn how we can filter data using where clause. In SQL, the where keyword allows you to filter based on both text and numeric values in a table. These are few different comparison operators you can use. So there are equal, not equal, less than, greater than, less than or equal or greater than or equal to sign. So take note that these comparison operators are like we're going to commonly use this or we're like using this all the time in executing our code or query. So to start, let's proceed with the where clause with an equal operator. So the first code that we're going to see is equal operator. So this one, equal operator. So the situation is the following query populate the list of employees whose first name is Hope. To retrieve the records, the query should be written as follows. So we're going to find the first name with Hope in our database. So these are our database, which has given a name with employee. So select is always the first word we should put in our query. Select first name from employee. So take note, employee is the name of our database. Employee were first name. We're going to find the employee that has first name with Hope. First name is equals to Hope. So the basic execution we're going to have this time. So let's run and see if there's Hope in our database. So there is Hope. If you can see here, Hope Chavez. There is Hope Chavez. And let's go back. So in the query, the predicate is where first name is equal Hope, which is evaluated as true. So let's proceed with the where clause with AND operator. So this time we're going to use the AND operator. So this operator. For that, I'm just gonna give you like a peek to not always code all the time. We can use this operator. So we're just gonna touch these two this time. We're just gonna touch the third part or the third column. So the situation is, I will show you how we can use the multiple predicates to population the desired records from the table. For example, we want to populate the employee whose employee ID is 12 and department ID is 2. To retrieve the records from the table, the query should be written as like this. So employee ID is equals to 12, and now this is how we're going to use the operator, and department ID is equals to 2 and semicolon. So take note that don't forget to put this at the end of your query or your code, the semi, because this is the final statement. So let's run this one. So we have 1. So exactly that, like what we expected. So Hyacinth Macintosh, so she is a girl. So she has employee ID 12, which is this one rather, and department ID 2, which is this one. So we include that AND operator in where clause. The expression is where employees ID 12 and department ID is 2. If both expressions are evaluated as true, then the entire expression is evaluated as true. So our code or query is, as we say, perfect, because we find the expected result that we wanted. So let's proceed with the where clause with OR operator. This time we're going to use the OR operator, this operator. So as I said a while ago that we're not gonna touch these two, so just gonna let sit in crazy. So OR. So the situation is like this. We want to populate the employee where department ID is 3 or email is at Yahoo. To retrieve the records, the query should be written as follows. So take note that in our database, we have two types of email. So our employees use at Yahoo at Gmail. So first we should find the where department ID is equals to 3, or this one I'm gonna use the or email is equals to at Yahoo and the semicolon. And let's see whose employees have the department ID number 3 and at Yahoo email. Let's run this one. So we have 4 employees. So the employee ID, department ID rather, 3. So 4 of them has department ID number 3, same. And as you can see, there are 3 employees who have at yahoo.com is Davison, Benson, Jackson, and there are 1 at Gmail because we summon the, we code the department ID number 3. So she has Camilla has department ID number 3. So she was expected to show or the database was expected to give her one of the results. And we include that or operator in where clause is expression that evaluated as true. Then the entire expression is like all of this that we're using as true. And we can edit you can edit it if you want department. If you don't want the department ID, you can have address, you can first name, and you can have last name, or wherever you wanted to. So let's delete this and proceed with another situation. So we're down to between operator. So the where clause between operator, this one. So the situation is you want to populate the employees whose employee ID is between 6 and 8. To retrieve the records, the query should be written as follow. So we're going to retrieve a record whose employee ID is between 2 8. So your employee ID between 6 and take note that we are using an operator here and 8 and semicolon. And let's run if the database we're gonna give her the result that we expected. So we're expecting employee ID with 6 to 8 to 6 7 8. So let's see. So here they are, 6 7 8. Employee ID 6 7. So there is Zachary, Austin, and Sasha. We include that between operator in the where clause, the expression is where employee ID is between 6 and 8. In the table, we have records, or the database have shown that they are employee ID 6 to 8, it is Zachary, Austin, and Sasha. The expression is evaluated as true and query return the result test. So, next line. Now we're going to use IND. This is like very hard to pronounce, but here, IND operator. This time we're going to use the IND operator. So the situation is we want to populate the customer whose employee ID is 9 8 10. To retrieve the request, the query should be written as follows. So we're going to retrieve employee ID whose employee ID is 9 to 8, and the query should be like this. Where employee ID, and take note of how I use the operators and close and open parentheses. 9 8 9 8 10 and close parentheses and semicolon. And let's run and see the result. So here they are. So employee ID 8 to 9 10. Just observe this again. We summon Sasha, Suzanne, and Petya, whose whose has employee ID 98 to 10, and we include that end operator in the where clause. The expression is where employee ID is named ID 9810. In the table that we have the employee ID 8 to 10, which is Sasha, Suzanne, and Petya. So our expression is evaluated as true in the query return the result set. And now we're down to our last session, which is let's go back with the comparison operators. So as I said, the comparison operators is equal, not equal, less than, less than or equal to, greater than or equal to. So this time we're just gonna do some basic using the greater than and the less than comparison operator. So the situation is like this. We want to populate the records whose employee ID is greater than 12. Then the query should be like this. So employee ID, where employee ID D is greater than 12. So take note, here is the greater than sign. So let's run this one. Oh, I forgot. So there's something wrong with this. Let's go back. I forgot that there's like no equal in this one. So
Hi everyone, I am Molo and we will be having a walkthrough with sorting and grouping clause. Without further ado, let's get started. Once you have learned how to filter data, it's time to learn how to sort data. The ordered by clause allows you to reorder your results based on the data in one or more columns. First, take a look at how the table is ordered by default. Now, let's see what happens when we ordered by one of the columns. You will notice that the results are now ordered numerically from first to third on the contents in the department ID column. This is referred to as ascending order, and it's SQL's default. If you ordered a numerical column in ascending order, it will start with smaller or most negative numbers, with each successive row having a higher numerical value than the previous. If you'd like the results in the opposite order or descending order, you need to add the desk operator. And here you go. The descending order in department ID column. The group by statement in SQL is used to arrange identical data into groups with the help of some functions. If a particular column has same values in different rows, then it will arrange these rows into a group. Group by single column means to place all the rows with the same value of only that particular column in one group. We can also list the number of employees in each country. So as you can see, here in the result, there are 5 employees in the US, and so on. An order by clause in SQL specifies that a SQL select statement returns a result with set of rows being sorted by the values of one or more columns. The sort criteria do not have to be included in the result set. Also, when working with research data, sorting is a common method used for visualizing data in a form that makes it easier to comprehend. Organizing records into logical groups often makes them easier to read and understand. For example, the second report in figures is grouped by the date field, so wait lang, ikat ani, balik. Organizing records into Again, organizing records into logical groups often makes them easier to read and understand. For example, the second report in figures is grouped by the date field so that you can quickly see how many sales occurred in the particular month. The quick sort is regarded as the best sorting algorithm. That is because of its significant advantage in terms of efficiency because it is able to deal well with a huge list of items.
Good day, I am Jhun Bryan. In this tutorial, I will discuss and execute some code snippets for aggregate functions and join clauses in SQL. SQL aggregation is the task of collecting a set of values to return a single value. It is done with the help of aggregate functions such as sum, count, and average. For example, we have here two tables, the department table that have the department ID as the primary key, department name, supervisor, and the annual budget. And the other table contains the employee ID, first name, last name, email, address, and department ID. Say for example that we want to count the number of our employee. So in order to do that, we should hit Tutorial, SQL, and key in the code. Select count employee ID. Since employee ID is used as the primary key, meaning it's unique from each other. Employee ID from the table employee and run. We have 13 instances of employee in the employee ID. That's how to use the count aggregate function. Another scenario. Say for example that we want to know the number of employees that live in a specific address. So in order to do that, we have to combine distinct and count functions. So let's go back to our code, and then let's type in the select distinct as the keyword for unique values in a column, address, and count. We are going to count the employee ID because, as what I said, it is unique. ID as the number of employees from employee table and group by address. As you can see, it is now sorted and grouped according to how many employees are living in a particular area. So we have here US have 5, Paris 1, Munich 2, London 2, and so on and so forth. So as you can see, we have used the group by keyword because that is in order to group rows with the same value. So yeah. And you may also notice the keyword as. So as is used as the aliasing. So in aliasing, it's just like in another programming language where you assign variable to values or values to variables. So it is this looks like the variable, and then this is the value. So this then was prompted to this table that is also called as the result table. So reminder that count simply returns the number value of the instance that you want to count. Moving on, the other aggregate function is called the average. So average, just like in statistics, it is the sum of all values divided by the number of all values. So let's go back to our table. Since there's no much numeric value here aside of the department ID, which is inappropriate if we're going to find the average of the department ID, we have provided here in our department table the annual budget. So it is the budget for the department for the entire year since it's annual. And then now we will going to find the average of the budgets. So in order to do that, you have to click edit inline. Sorry. And SQL select average, it's AVJ, and the annual budget from department table. Yep. As you can see, it's not tallied. So the annual budget is 60,070. it returns the average of the columns that we want to query. The next aggregate function is the sum. So sum returns the total sum of a numeric column. So let's go back to our department table, and here we're going to figure out the sum of the annual budget for these 3 departments. So we just go back to our tutorial and then our SQL tab, and then select annual, its sum of the annual budget from department table. And here now we have the sum. So very simple, it's very basic. It's like the total of all the values that were stored in the department table here. Now let's proceed to aliases or SQL aliases. What is SQL aliases? Aliases are used to give a table or a column in a table a temporary name. Aliases are often used to make column names more readable. An alias only exists for the duration of the query. An alias is created with the as keyword. So, for example, here in the department, we want to figure out the quarterly budget for the entire department. So, we're just going back to our database again, and prompt, then we have to select sum of the annual budget divided by 4. Let's enclose it, and from department table. So if we are going to run this code snippet, of course we're going to get this sum, and then enclosed with parentheses and annual budget, which is the attribute for the budget, divided by 4, and then yep, the quarterly budget is correct, but the label is kind of confusing, right? There are so many characters that was written. So an alias can actually solve this issue. So by just going to add the as keyword and then the variable that you want to use. So let's use quarterly budget and go. So as you can see, the label or the label of the attribute is now changed with more simple value, which is the quarterly budget, and there's no added unnecessary characters that you want. So yeah, it's quite simple. You're just going to add the as keyword in order to use the alias function or the alias keyword. Aliases can be useful when there are more than one table involved in a query. Functions are used in the query. Column names are big or not very readable. Two or more columns are combined together. And now let's proceed to the join keyword or the join clause. Say for example that we want to know an employee's designated department. So in order to do that, here in the employee table there was a department ID. So department ID is a foreign key from the department table. So this column here, this attribute here, is linked with our department table here. So we are going to use that in order to fetch information from the different table. And in order to do that, we need to use the join clause. Here I want to fetch the employee's first name, last name, and the designated area. So in order to do that, we have to select employee dot first name and employee dot last name, and we also want to fetch the department name. So as you can see here, we use the dots, that is to link attributes to their respective tables. So here we can know that the first name attribute, we are referring to the attribute that was assigned here in the employee, as well as the last name that is assigned here in the employee table, and the department name that was stored in the department table. So in order to do the process, we have to utilize the two tables here from employee left join department. So as you can see, the employee and the department that we are talking here is the entire table. So basically we want the department table to join in the employee table. So in reality, there are different types of join clauses. So but we are only using here the left join. So left join keyword returns all records from the left table and the matching records from the right table. The result is 0 or null records from the right side if there is no match. So let's going to try it. Left employee dot, oh, I forgot the on employee dot department ID is it equal to department ID, and we also want to order or sort it by the employee's first name, employee dot first name, or let us run. So as you can see, the first name is now showed like Austin. He is assigned to the design department, Camellia in design, Halbert in marketing, Haven in design, Hope IT, and so on and so forth, as well as their last name. So let's discuss the code. The department ID that we input here came from the employee ID. So if we open this into a new tab, codes. Okay. So the department ID that we refers here is the department ID from the employee table. And then the next table, the department table, we use the department ID, which is common in the both table. So here, this one is the department ID, which is also the primary key for this table. So the primary key here was utilized in the employee table in order to fetch related information across tables. The different types of SQL join includes the inner join, It returns records that have matching values in both tables. Left join that I have already used. Right outer join returns all records from the right table and the matched records from the left table. Full outer join that returns all records when there is a match in either left or right table. Actually, there are another more complex joining procedures in SQL, but it's too complex, so we're not going to tackle it here. So basically, that concludes my part for the basics of SQL. Thank you.
SQL is now applied in the medical field. The launch of the electronic healthcare record has emphasized the importance of data in the healthcare industry and to improve the quality of the patient's health. Furthermore, data is now being captured in a data repository for analysis purposes. That is why nurses, doctors, and other healthcare staff members is required to know how to retrieve information from a database. Structured Query Language or SQL is used to extract information from a relational database to address an array of information needs. It can collect information about healthcare operations, every piece of data that is collected from the patient, such as medications, prescriptions, operations data, and many more. That is why SQL is important in the medical field. That is all, and thank you.
Hi guys, so another trivia. So did you know that there are cool things for SQL project for beginners? So I have compiled some interesting ones for you. So the top SQL project ideas for beginners is number 1 is the library management system. Number 2, centralized college database. Number 3, student database management. Number 4, online retail application database. And 5, inventory control management. 6, hospital management system. 7, railway system database. 8, payroll management system. 9, an SMS-based remote server monitoring system. And lastly, blood donation database. So when you build and design a database with real-life applicability, it will not only refine your conceptual understanding but also boost your problem-solving skills.
What's up guys? My name's Jmarco P. Geraga, and let's have some break and I got you a trivia. Did you know that in 1973, Chamberlain and Boyce started working on SQL, and what they called was SQL. The full form of SQL is Structured English Query Language. After that, they have changed it to SQL due to a trademark conflict with a UK aircraft company. That's all for the trivia guys. I hope you learn a lot. Peace.